So now that we've gone about the business of treating a vector in the same way that you would an array, what I'm going to tell you is that that is not a perfect solution for all of your data needs. As I've been mentioning, as a developer, it's not always certain that you are going to be knowledgeable about how big the data set is. If I'm going to treat an array, or treat a vector rather, in the same way that I'm going to treat an array, it suggests that I'm going to have to know how big it is, so that as I'm reading elements in, I can refer to a specific element number, like by using a loop with that index value. But what happens if I am trying to add data to essentially the back end of an array or a vector that is larger than it is that I declared it? That is what we need push and pop for. Kind of the way to think of this is push and pop are the way that a vector works, and it's very much like the plates at a buffet. So it's Sunday. This is an online class. So Sunday morning, you roll out of bed at the crack of noon, and you're like, well, I ain't cooking. So let's go for brunch. Brunch, as we're all aware, has less than breakfast and less than lunch, but it costs more than the both of them put together. So as you are at your brunch location, after you have clearly secured your Bloody Mary, which is disgusting, after you have secured your beverage for the day, you go about the business of cramming your pie hole full of food, right? So as you go to that stack of plates, that's really a vector. Over the course of a day, it's impossible to tell that restaurant how many plates it is you're going to need for today in order to assure that you can feed all of your belligerent and hungover customers. As the bus people come out, they add more plates to the top of that stack. This is like push. What we're essentially doing is we are adding elements to our array. So if we think of, or in this case, our stack, or vector rather. So as we think of that plates as a vector, I can never tell how many plates it is I'm going to have to refresh that stack with over the course of a day. So as I need new elements, I push them onto the top of that stack. So as a new customer comes up, or as a customer comes up for the second, third, fourth, and fifth time, this is, after all, the Midwest, what they're going to do is pop. They are going to take a plate out of the vector. They're going to remove the last plate that was put in, essentially. So this idea of push and pop. Push back is what we do for the vector when we want to add something to the tail end of a vector, and the vector is of a size we don't know. We have to use pushback. We'll talk about this in a second. When we want to remove an element from the back end of that vector, we would pop. We would remove the last element. Whatever the element number is, it doesn't really matter. Again, the vector knows its own size, so when we use pop, it's going to simply remove that for us. If we wanted to point to the text, we can do so. Let's just use the best example we can see here in the text. That's on page 436. If you look at line 34, essentially what we're seeing here is pay rate dot push underscore back. So pay rate is the name of our vector. Dot is, again, a call to the function in the standard template library, and that is pushback. And then inside of the parentheses is going to be temp rate. Temp rate is a value we have just read in from the operator, and that value I want to save to the tail end of my vector. So what you'll notice is if you flip back to page 435, in the declaration of my vector on lines number 10 and 11, I am not giving my program an idea of the size of the vector. So I'm not saying, this is 10 elements, this is 100 million elements, etc. I'm saying, here you go, environment, figure this stuff out for me. Because of this design consideration, that means I can't simply use the typical array language like we would in the previous podcast, because the array language suggests that I know how big my vector is. In that case, you could have just used an array. So the change we have to make here is to use that push underscore back. What that's going to do is push that element to the very back of your vector, to the very last position there. The environment is going to go ahead, and the very next excuse me, storage allocation that is available is going to become that value that we push there. So here on page 436, after I've read in the hourly rate, you'll notice it's called temp rate because I'm going to go to the next employee, the next employee, the next employee. This way I don't have to build a vector around how many employees I know I have. If that's a number that can grow and shrink at any time, a vector is a really good, valuable data structure to use. So pushback is what we have to use programmatically if we don't know how big our vector is. Frankly, this is probably the safer way to go. If you start a vector with a size, so unbelievably big, you as a developer are 100% positive that you're never going to go over it, you should have used an array in the first place. The value of the vector here is the perpetual resizing that the environment can do for you. So push back is what you're going to use there. On the other side, if I want to remove elements from a vector, we can see that on page 439. It's essentially line number 28. You can see there in the little code sample they give us. In this case, values is the name of our vector. Values.popback, pop underscore back, and then open parentheses. The reason I can use the open parentheses here is, again, a vector knows how big it is. It knows what the last element in that vector is going to be, and it will simply remove that one for you. This turns out to be a really great way to do data validation. So if you've read a value into your vector and then you do data validation, you can say, if the values have to be between 0 and 100, you can do the validation after you've read your value in and say, oh, they entered 101 or they entered 1,000,000. Either of these are going to be bad values. You would use that pop back and simply remove the last element in the vector and continue on. So pushing and popping is the way you would manage new elements into or previous elements out of a vector if you do not know the starting size of that vector. And again, it takes the brunch analogy. The push simply adds one to the back end of the vector, and the pop removes that one from the back end of the vector as well.